Welcome everybody to this presentation of the hormone ghrelin. Ever wondered why your stomach starts growling at you? Well, this is down to the ghrelin hormone that circulates in your blood. Ghrelin is a gastric or exogenic peptide hormone. It's a 28 amino acid peptide synthesized by endocrine XA-like cells of the fundus mucosa, produced mainly in the stomach. Ghrelin secreted from the stomach stimulates efferent vagus nerves, sending messages to the hypothalamus to increase our appetite. The hypothalamus releases the hormones that travel in a local circulation to the anterior pituitary gland, which exert effects on growth and metabolism. So why is ghrelin released? Well, basically, when we have fasted or not eaten for a while, it's our messenger signal to let us know we need to replenish food stores. Plasma ghrelin levels increase, which, as we spoke about, act on the hypothalamus, which trigger a response. This response is us consuming food. We need to replenish our food stores. When our food stores are replenished, our ghrelin levels start to decrease. Satiety is then reached, which is our hormone leptin, so the leptin levels increase, and it's a negative feedback to the ghrelin, so then we don't eat for a while, we go back to our fasting state, and our ghrelin levels start to increase again. So ghrelin and leptin work as opposites. Leptin is a protein hormone made by adipose tissue cells, which help regulate our energy balance by inhibiting hunger. So when leptin turns off, when our satiety has diminished and we've stayed hungry for a while, then ghrelin turns back on again. So when one switch is on, the other is always off. So ghrelin exerts a wide range of physiological roles, and it interacts with many other hormonal systems. Ghrelin is a fast-acting hormone to initiate food intake. It also acts on glucose homeostasis by inhibiting insulin secretions and regulating things like gluconeogenesis and glyconeolysis. It stimulates acid secretion. It's also essential for growth hormone. It decreases thermogenesis to regulate energy expenditure. It works on many other systems in a negative feedback loop. Ghrelin uses a G protein coupled receptor and is a natural ligand for growth hormone. Growth hormone secretory increases intracellular calcium levels through the receptor, which signals the pituitary gland to release growth hormone. The growth hormone then inhibits ghrelin secretion. Prader-Willi syndrome is a disease state in which ghrelin function is altered. It's a rare neurodevelopment disorder with many chromosomal defects. In early infancy, the main characteristics are hypotonia and feeding difficulties, followed shortly after with excessive eating and obesity in early childhood. There are other side effects as well, which are cognitive impairment, short stature due to the lack of growth hormone, There's a dysfunction in the feedback system. So the lack of growth hormone is also a problem to switch off the ghrelin. As we looked at in the last slide, ghrelin stimulates growth hormone, but in Prader-Willi syndrome, the feedback system isn't working. The ghrelin is not stimulating growth hormone because there's a lack of growth hormone. And as we saw, growth hormone then is actually like an off switch for ghrelin, and this is not occurring. So in Prader-Willi syndrome, we get heightened ghrelin secretion throughout the blood, causing children to be hungry a lot, which means that they're then overeating, and obesity is a huge problem for the Prader-Willi syndrome. Thank you everybody for watching.